Hello everyone and welcome to episode 7 of Zero to Hero, full stack plus VoIP plus AI engineer. I am Siddhant Kumar, full stack, VoIP and AI engineer working professionally since 2021. In the last 6 episodes, we set up WSL2 and configured VS Code, installed our tools, connected to GitHub, added pre-commit hooks and learned environment variable management. Today, we are taking a huge leap forward, running multiple services with Docker Compose. Think of this like learning to conduct an orchestra instead of playing one instrument. Instead of manually starting your app, then your database, then your kit, you will define them all in one file and start them with a single command. By the end of this video, you will know how to write a docker-compose.yml for a Python app with PostgreSQL and Redis. Start all services with Docker Compose up. Connect your app to the database and cache. Stop and clean up with Docker Compose down. This is the exact workflow used by professional teams to develop, test, and deploy applications. Let's start conducting. Before we type any commands, let me explain why Docker Compose matters, and I will keep it fun. Think of your application like a restaurant kitchen. Your app is the chef preparing the dishes. PostgreSQL is the pantry, storing all the ingredients data. Redis is the expeditor, caching frequently used items for quick access. Now, without Docker Compose, you would have to hire the chef separately, stock the pantry manually, train the expeditor, hope that all show up at the same time. With Docker Compose, you write one recipe, the docker-compose.yml, that says, I need one chef, one pantry, and one expeditor. Start them all together and make sure they can talk to each other. Then you run one command, docker compose up, and just like that, your kitchen is open for business. This isn't just convenient, it's how professional teams ensure consistency across development, testing, and production. So let's write that recipe. First, let's create a simple project structure for our demo. In your terminal, navigate to your project root. Mine is 0 to hero. Create a new directory mkdir. Now the directory name, I can keep any, you can keep yours. So Ep.7-docker-compose. Now navigate to created directory by entering this command cd episode-7-docker-compose. Now create two files, touch app.py space, the other file is docker-compose.yml. Open them in VS Code editor by typing code app.py space docker-compose.yml. We will start with the docker-compose.yml. This is our orchestration file. In docker-compose.yml, add this content. We will learn how to write this file word by word in upcoming videos. For now, just pause the screen and write this file, or just wait for my videos in which I will teach you how to write this file. Let me break this down. We define three services: app, DB, and catch. The app service builds from our current directory, exposes port 8000 and depends on DB and catch. The DB service uses the official PostgreSQL image with environment variables for credentials. The catch service uses the official Redis image. We use named volumes to persist data between restarts. The app service mounts our local code as a volume for live development. This is a production-ready pattern. We will refine it later, but this gets us started. Now, let's create a simple Python app that connects to PostgreSQL and Redis. In app.py, add this code. You can copy and paste from this episode document file. You can find the link in the description or on the GitHub page. I will also create a video how to write this program file soon. For now, this app connects to PostgreSQL and Redis using environment variables, has a health check endpoint that tests both connections, return JSON with connection status. Now we are going to create our requirements.txt file, but not by guessing version numbers or copying from internet. Instead, we are going to let PIP do the work for us. Think of PIP freeze like a photographer taking a snapshot of your package installed. It captures exactly what you have with the exact versions and write it all down for you. No typos, no guesswork, just a clean, accurate list of dependencies. Let's see how it works. First, make sure your virtual environment is activated. You should see VNV at the start of your terminal prompt. Now, let's list the package by typing command pip list. For now, apps we need Flask, our web framework, PSY cop G2 binary, the PostgreSQL adapter, Redis, the Redis client. Now we will generate our requirements file. Type command pip space freeze less than space requirements.txt. Press enter. What just happened? PIP freeze list all installed packages with their exact version. The less than symbol redirects the output into a file called requirements.txt. Now let's verify it worked. Type cat requirements.txt. You should see same output as PIP list. Perfect. Every package, every version captured automatically. This file is now ready to be committed to Git. When someone else clones your repo, they can run pip space install space -r space requirement.txt and get the exact same environment. If you ever add a new package later, just install it with pip install, then package name, then run pip freeze space less than requirements.txt again to update the file. Simple, reliable, professional. Now create a Docker file for our app. You can pause the screen and type the configuration of this file, or you can also copy and paste from the document file of this episode. I will also come up with a video to share you how to write this file. This Docker file use a lightweight Python based image. install our dependencies, copies our app code, expose port 8000, runs our app with Python app.py. Now the moment of truth. Let's start all our services with one command. In your terminal, type docker-compose space up space dash dash build and press enter. Now watch what happens. This is where the magic begins. As the command runs, you will see a lot of text scrolling by. Don't panic, this is normal. Here's what's happening. First, Docker Compose is creating a network. This lets our services talk to each other privately. Then it's pulling the PostgreSQL and Redis image. Think of this like downloading pre-built containers from a warehouse. Next, it's building our app image. This runs the instructions in our Docker file to create a custom container for our Python code. Finally, it starts all the three services in order. Database first, then cache, then our app. When you see this line app-1 or star running on HTTP link, this means your application is live and accessible at HTTP link is to 8000. But I know that's a lot of output to trash. And here's where AI can help. If the output feels overwhelming, here's a pro tip. Copy the terminal output and paste it into any AI tools like ChatGPT, Claude, or Gemini. Then use a simple prompt like, please explain this Docker Compose output in simple sequential steps. What happened first, second, third? What does each line mean? The AI will break it down for you line by line in plain English. Now, here's the important part. AI is a powerful co-pilot, but you still need to be the pilot. In this course, we will learn how to use AI effectively. But your foundation must be strong first. Why? Because right now many AI tools are free or generous with tokens, but soon they may run on a token-based or membership model. If you understand the fundamentals, you can ask smarter, more specific questions, which means fewer tokens, lower cost, and faster answer. Think of it like this. If you know what a volume mount is, you can ask, why is my volume not persisting data? Instead of, why isn't my data saving? And get a precise answer in one query instead of 5. That's how you use AI wisely, token-wise, cost-effective, and efficient. Now that our services are running, let's test them properly. First, split your VS Code terminal into two panels. Click the split terminal icon. This lets us run commands and watch logs side by side. In the right panel, let's test our app endpoint. Type curl space HTTP link. You will see output, but it's all on one line, hard to read. That's because curl returns raw JSON. Let's make it readable. We will use a tool called JQ. It's a command line JSON processor that formats and filters JSON beautifully. As JQ is not installed, So first install it. Enter your password when prompted. This installs JQ system wide. Now run the same curl command but pipe the output through JQ. The OR symbol is called a pipe. It takes the output of the first command and feeds it as input to the second. Now you see message hello from Docker Compose, database connected, Redis connected, world, timestamp. So this confirms our Flask app is running and both PostgreSQL and Redis are connected and responding. Let's clear the terminal for a clean view. Now let's test our database directly without going through the app. Run this command. Let me break this down. docker-compose space exec runs a command inside a running service container. db is the service name from our docker-compose.yml. PSQL is the PostgreSQL command line client. -u user specifies the database user. -d mydb selects the database name. -c select now close bracket runs the SQL command to get the current timestamp. You will see the output like this. This proves PostgreSQL is running, accepting connections, and our credentials are correct. Now let's test Redis the same way. Run this command. Breaking it down, catch is our Redis service name. Redis-li is the Redis command line interface. Ping is a simple health check command. Expected output is pong. That's it. Redis is alive and responding. Simple but powerful for quick health checks. Sometimes you need to see what app is logging, error, requests, debug info. Run this command. This shows the captured logs from the app service since it started. You will see Flask startup message, request logs, and any errors. This is useful for post-mortem debugging, seeing what happening after a request failed. But what if you want to watch logs in real time, like tallying a file? Add the -f flag for follows, like docker-compose space logs space -f space app. Now you will see live streaming logs. Every new request, error, or debug message appears instantly. This is invaluable during development. You can watch your app react as you test it in browser. To stop following logs, press Ctrl+C. When you are done testing, it's time to stop this service. First, if you are still following logs, press Ctrl+C to exit. Then run docker-compose down. This command stops all the running containers defined in docker-compose.yml, removes the containers, removes the default network created for the project, keeps your volumes so your PostgreSQL data and Redis cache persist for next time. If you ever wanted to remove everything, include data volumes, add the -v flag, like docker-compose space down space -v. Warning: this deletes your database and cache data. Only use this when you intentionally want a fresh start. For now, we will keep our data, so just run docker-compose space down is perfect. Let's recap what we configured today. Created a project structure for a multi-service system. Wrote a docker-compose.yml defining app, PostgreSQL and Redis services. Created a simple Flask app that connects to both database and cache. Built a Docker file for our Python application. Started all services with docker-compose space up space dash dash build. Tested the application and verified all connections. Stopped and cleaned up with docker-composed space down. Review best practices for production-ready Docker Compose files. You now have the foundation for developing complex multi-service applications locally, just like professional engineering teams do. If this video helped you, please subscribe to Hero Stack Academy and hit the notification bell. Episode 8 will drop soon. This course is 100% free and open source. If it helps you, consider becoming a GitHub sponsor. Your support funds server cost, domain renewals, and more free content. The link is in the description. Join our Discord community. The link is in the description. Share your steps, ask questions, and connect with other learners. Start the GitHub repository. It helps others discover this course. I'm Siddhant Kumar, full stack, VoIP, and AI engineer, working professionally since 2021. This course is my passion project to help developers like you master enterprise-grade skills through hands-on learning. You can connect with me on LinkedIn, GitHub, or via email. All links are in the description. Drop a comment below. Compose ready if your multi-service app is running. Thank you for watching. I will see you in episode 8. Happy coding!